Hi everyone. We are going to begin the presentation of Percoco about a queuing and authentication service for OpenStack. Please switch off your cell phone and enjoy.
Ready? Okay, let's get it started. So, hello everyone. Thanks for being here, first of all. So this talks about a new project we started earlier this year, in January actually. It's called Marconi. It's queuing and notification service for OpenStack, made and for OpenStack. So what we're going to talk about today about Marconi is what it is and what it is not. Better now? No? Okay, cool. Anyway, about the architecture and about the API, the version 1. Before starting, a few words about me, same words I said in my last talk. I don't know, so I'm very proud of Hatter. I'm part of the MongoDB Master Group and I'm very passionate about programming, so I'm always thinking about programming. I'm also part of the RDO community, and RDO is the Red Hat community behind OpenStack. So we're basically making sure OpenStack works perfectly on every single Rails-based distribution we have support for. What is Marconi? Marconi is a queuing service, which means we have queues, obviously. We support messages, and we have claims for those messages. So basically, with Marconi, you are able to give queue as a service and have clients that create queues dynamically, and you can build them for those queues. Those queues have some properties and metadata that you can set to those queues, and you can also send some messages through those queues and have different messaging patterns applied to those queues, to each single queue. We also have claims, which is a way to claim some messages and be able to do some work on those messages. And every single of these items we support, let's call it items we support in Marconi right now, have specific properties that you can apply, like TDLs, like bulk inserts and timeouts and match size and all that kind of stuff. It is a messaging service. Right now, we support just request and response pattern, and we're working on the publish and subscribe one. It depends on the protocol you're using and the way you create messages in the queue and the properties of your queue, right? So right now we just have request and response pattern. It is a very young project, so it has many bugs in there. It's many work in progress ideas and many things we are discussing right now. So if you are interested in the topic, this is the right time to jump in and be part of this new project. It would be really cool to have more contributors and people sharing some cool ideas about what a queue service should do or shouldn't do at all. So we're still defining what the project should be like. We have an API, so for those things I just talked about, like queues, messages, and claims, we already have an API in version 1. But I don't see that API changing any time real near. But the ideas behind it and the things it is doing, those can change, definitely. Anyway, I have missing pieces. So if you think something is missing and we are not considering something that should be considered for this project, that would be really cool to hear. It is not a replacement for Qpid, RabbitMQ, or any existing message broker. So we are not creating yet another message broker. That's not our goal. That's not what we want. We actually would love to have this service on top of existing message brokers, so that you can provide a service based on RabbitMQ itself or Qpid itself to other clients and have Q as a service on top of those services, right? So we don't want to replace them. So don't try to just trash RabbitMQ and put Marconi in your deployment, because it's going to fail really badly. But we do want to be fast as possible, right? So we are developing this whole stuff to be really, really, really fast, and trying to consider every single aspect about it, and making sure that we optimize the API and the whole HTTP transport, every single transport as much as possible, and that talks to the backends we have. And it is not incubated yet, so it doesn't respect any release cycle. We try to respect release cycle we try to keep track of every single release cycle in OpenStack. So we have blueprints that are actually targeted to every single checkpoint in our release cycle. So we have H1, H2, H3, which are Havana 1, Havana 2, Havana 3, which is their current release cycle. But it's not an incubated project, so we don't have an official PDL right now. We don't have a we are on StackForge. We are not on the OpenStack organization. If you look for us on GitHub, you should look for us on StackForge instead. But we're working, we're getting there. So we already have the whole incubation page ready, and we would like to apply it very soon. So it's growing as a project, but we need more contributors. There are a few contributors right now, like 4 or 5 people counting me. So there are just a few folks working on it, and we need more contributors to make sure it succeeds. So let's talk a little bit about the architecture. As every single OpenStack project, it is being developed in a plugin-based fashion way, right? So we have plugins for both layers. We have 2 layers, basically, those 2. We have transports, which is the layer that is exposed to every single client. So when clients query Marconi or do some operations on Marconi, they're actually talking to the transport layer. And we also have the storage layer. The storage layer is the layer that talks to every single backend we have, right? Both layers are pluggable. So the idea is to support multiple transports and have multiple storage backends, like I said before, so that people can use whatever they want and what fits better for their deployments and their infrastructure. I'm going too fast. So about transports, as I said, it's pluggable. So right now, the only transport we have is HTTP, and the API was developed on top of that. We're willing to create a new transport which is based on ZeroMQ. The idea about ZeroMQ, so before all security questions start, the idea about ZeroMQ is not exposing it to the public, right? So like making a service based on ZeroMQ and just saying like connect there and do whatever you want. We do want to have some authentication and ACL or role-based access control on it, and that's cool. But the idea about ZeroMQ is having some kind of transport that is fast as hell, but having it in a private way, right? So you can have it in your private cloud and just talk one server to another and use it in your private server. It would be really nice to have it in a public server, but I see many security holes in there, so I wouldn't suggest that. So for the HTTP transport, we're using Falcon as a WSGI library. The reason why we're using it is because Falcon, the last benchmark we did, was still the fastest one. And it's not the more mature one, I would say. It's not the most, it's stable enough and it's fast, it's really fast compared to other WSGI libraries like Pecan, for example, or WebAll, right? But it's not that full-featured. It's not that full-featured. It's still missing some features, but we're contributing back to the project as well. So making sure that it gets better and we can improve it while we're improving Marconi itself. We don't ship any container. So we just ship the WSGI app, right? So that every single deployment can choose whatever container they want. We don't want people to be tied to a single container. Like we are using Unicorn and you will have to use that forever. No. We don't want that. We do have a really simple based on WSGI ref, which is an internal standard library. It's part of the Python standard library. So we do have some way to just start the server and just make some calls and make sure it works and have some way to test it and have functional tests on top of it. But that's not meant to be used in production. So for production environment, you can use you can use whatever you want, like WSGI or Unicorn or just Nginx and having some sockets. I don't know, whatever you want. As for the storages, we have we support two storages right now. We support SQLite. That was kind of a bad move, actually. Yeah, laugh. That was kind of a bad move. I mean, we were talking about supporting SQL Alchemy instead at the beginning, but we wanted to create something really fast. I mean, we wanted to ship that stuff and see if it works and if the idea made sense, right? So for some reason, we just came out with this awful idea like using SQLite. And yeah, it works. But the thing is that we now want to support MySQL as well, and we like to support PostgreSQL as well. So we do have to implement SQL Alchemy anyway. So since SQL Alchemy has already support for SQLite, it would have been better to have it since the beginning. But anyway, that was a bad move we did. We have support for SQLite and we have support for MongoDB. MongoDB is the one we suggest right now to use in production environments. So, disclaimer, Marconi is not ready for production. So let's not go just leave the room and just trying to install it in production. But it's not ready for production environment with my whole honesty. It needs to be, it still needs some load tests and making sure it's capable of handling really, really, really huge workloads and still be fast, right? But we are getting there. We already have an environment to test that, and it's all provided by Rackspace, so thanks guys. We have an environment ready for it, and we are going to start doing load tests in that environment, so making sure it's capable of handling all those. So the storage we suggest for production environments right now is MongoDB. So we choose MongoDB. That's not my fault, I swear. So we choose MongoDB because it was easier. I mean, it was the easiest thing we had to implement a cool API and make sure that the storage API itself, not the HTTP API, the storage API itself made sense and it could be used for other storage backends as well. So MongoDB is working pretty well right now. It wasn't straightforward at all. I'm not gonna lie, it wasn't straightforward at all. We are still struggling with some stuff about MongoDB, like transactions, everyone knows that. But yeah, because we need some transactions to implement the whole stuff of the queue. I mean, we need to have our own counter, and we need to increment that counter, and we need to, we need that to happen in a single transaction. We don't have that in MongoDB, right? So we're still struggling with some stuff, but we figured most of the things out, and it works very well right now. I'm pretty sure there are better ideas of the ones we already implemented, so if you go there and have better ideas, just chime in and let us know. As for authentication, we are using Keystone. Keystone is the authentication module for OpenStack. We want to integrate with OpenStack as much as possible. So we're definitely going to use every single OpenStack tool we have. And obviously our first thought was to implement Keystone as authentication layer. And we are thinking about having other authentication plugins and being capable of supporting other authentication stuff so that each deployment, each infrastructure can have its own authentication layer based on middlewares, I guess. So right now we're doing that with middlewares for Keystone itself. So the idea is to support more authentications so that people can have their own authentication, maybe their own access control, so it would be easier to integrate with separate infrastructures that are not actually using OpenStack itself. So a few words about the API. The API is RESTful, and RESTful means many things and nothing at the same time. So we're trying to say, yeah, everybody's saying like RESTful. Yeah, my API is RESTful, that's fine. No. No, the API, what we're trying to do is like thinking about, obviously, that's kind of one of the bases about RESTful API is about thinking about resources, obviously. So we're trying to keep it that way and making sure that every single command that it's issued to Marconi is made in a resource fashion way. So you can just modify queues as they were records in a database, which they are, basically. And the same thing you can do with messages and that kind of stuff. This is going to be a real issue when we want to we will implement other storage backends like RabbitMQ, so we most likely won't be able to change many of those resources that are actually in RabbitMQ, like messages. We won't be able to modify those messages because RabbitMQ doesn't allow you to do that, and I don't think any of the message broker actually does. But we are thinking in that way. So the API is basically being created in that way. We have a plan that's a really small font. Anyway, we're definitely planning to keep consistency in the API. For keeping consistency in the API, I mean throughout the whole transport. We want to have the same API for the ZeroMQ transport and the same API for every transport that will be created in the future. So if you issue some kind of post action on the RESTful API for creating a message or posting a message, we want to have the same API in the ZeroMQ. Right? You don't have post requests in ZeroMQ, right? You just have a socket that you can write to, and the message goes. So we're defining that API as well to make it as consistent as possible with the HTTP one. I'm not saying we are going to implement the post and get and head method in ZeroMQ, but we'll try to keep comments, at least comment as consistent as possible. So I didn't want to do this, but I'm going to do this anyway. Marconi is kind of SQS and SNS from Amazon. Who of you knows what SQS and SNS from Amazon is? So, okay, some hand. So basically Amazon AWS has this service, it's called SQS, which is queue as a service, and has as well SNS, which is notification service. What we're doing with Marconi is we took those both services and put both in the same project, and that's why Marconi is queuing and notification as a service. I'm saying this because you don't have FIFO in SQS, and we want to guarantee that. We want to guarantee FIFO and making sure that messages are delivered in the same order they were posted into the queue. It's not that trivial for some backends, and that's one of the things we struggled with MongoDB. So because you have a 1 second granularity using, if you use MongoDB's objective keys, you have up to 1 second granularity. So you can guarantee FIFO up to 1 second. Under that second, you cannot do that. So we had to implement our own way to guarantee FIFO, even using MongoDB itself. So I'm pretty sure that's going to be easier with other storages, but we have, yeah, that's kind of the diversity we have in Marconi right now. We want to implement many storages, and we're pretty sure we will face some huge and really bad issues and bad things with many of them. So you can access messages and you can access messages and have these properties every time you access those messages. You can have paginated messages and make sure you get you can limit those messages up to something. This is part of reducing the number of calls you're actually doing to Marconi, so that you can get a bunch of messages at the same time. Instead of getting one for each request. And it's kind of, I mean, it's kind of normal stuff for when you're doing a web application, you always paginate your resources, right? So that's implicit. But when you're doing a message service, it's not that implicit, it's not that obvious that you would want to get a bunch of messages and reduce the number of calls, because it's supposed to get many calls and have huge workloads. So you can do that. And we're working, it's not ready yet, we're working on the stream, stream API. We want to have some streams so you can just register and get messages that are being pushed to your client. So that's part of the pub sub we're working on right now, so that you just have to do a single call and get all your messages and register to a single queue. Marconi is, I would say, it's like 100% customizable, so you can just change whatever parameter you want, and we want to keep it that way. The reason for that is like, so going back to AWS services, Amazon allows you to post up to, I think it's 256 kilobytes of messages, I guess something like that. So we also have those limits. We allow like every single deployment to set their own limits of how many messages can be inserted at the same time and how big those messages can be, so that you can just make sure your whole infrastructure is capable of handling that workload, and just tune it as you wish for your infrastructure so you can make it work better. Queues can have custom metadata as well, so you can store whatever you want in those queues, like not just the name, like having custom properties for your own usage. Like if you want to have a queue that has some building properties, like for this queue I'm going to build that much, and for this other queue I'm going to build that much. Those properties are meant to be, some of them are meant to be private, some others are meant to be public, but you can store whatever you want there, and we limited the name of the queue to 64 bytes. So we can reduce also the storage that's being used. So as for messages right now have these two main properties. So every single message have a TTL, and once that TTL is reached, the message will be deleted from the queue if it hasn't been processed yet. And you can enable or disable the echo, which means that if you use echo false, you won't get your own messages. So you can make sure that some producer doesn't get its own messages. So these are kind of, so for people that have been around queuing systems and distributed systems, some of this stuff may be really like obvious and should exist in every single queuing system, but they don't all the time. We also have claims for, we also have TTLs for claims every time you claim a set of messages. So claims work like, we have queues, and every single queue you can post messages to queues, and you can have like, say you have 100 messages in a queue, and you have 5 producers, and you want each producer to get 10 messages and work on those messages. So the producer does a claim to the service, and it blocks the messages and say that these 10 messages are mine, and I'm going to work on those, and it has a limit to do that job. And it blocks those messages, and it can query those messages at different times. It doesn't have to get them all in the same query. It just can block the messages and get one with each. Like, give me another of my claimed messages. So that claim has a TTL as well. It blocks those messages for that for that time. And once the TTL expires, those messages get a grace time, which is like a bonus time, like a lifetime bonus they can use to be processed by other producers, right? So since they were claimed, the idea is like we make sure that no message is lost. So that all producers can get every single message and work with those. So we implement this stuff called grace, and we just give a lifetime bonus to each message once they are released. We're getting to the end here. There are some operations that we're doing in a best effort fashion. I know how that sounds, but so for example, for bulks, we support bulk insert. So you can just post like 100 messages in a single call. The thing about bulk is like since there might be many race conditions when you are inserting messages and you want to guarantee FIFO. When some of these race conditions are met and we actually caught them, the idea is to retry that bulk insert as many times as you configured it. But if we reach the limit of times we can retry that call, we will answer with a partial bulk insert, telling the client how many messages were inserted, which messages were inserted, and which weren't inserted, so that the client can retry, can issue another call for the remaining messages and try to insert them all. Same thing happens for claims, but the claims is let's call less harmful, because when you try to claim 50 messages, and this is basically it all depends on the backend storage you're using. This is something that, to be fair, we had to implement for the MongoDB one. So since we don't have transactions, we need to get a set of messages from the queue that we can block, that we can claim, and then update them and say that they are claimed. Between those two queries, anything could happen, right? So if for some reason we are not able to claim them all, we will just reply with the claim with the number of messages we were able to claim. So say if the client tried to claim 50 messages and we just claim 30, which will reply with those 30 messages, and the client will try to claim another 20 in a second time. Right? So that's kind of the best effort philosophy between those two operations. I know that, again, I know how that sounds. It's not that like we all want the API to work in a best effort way. Like, I'm gonna try this, dude. If I don't able to do this, it's up to you. So no, we don't want that to happen. But it depends on the storage backend you're using, right? So for other storage backends, this might not happen at all. So some benefits about using Marconi, because this is another question I get many times on IRC mostly and mailing list. So what's the benefit about using Marconi? We have RabbitMQ, we have Cupid, we have ActiveMQ, whatever message broker you want to say. The idea is exactly have it as a service. So you're not going to install RabbitMQ and put it out there and say, people use it, I'm going to bill you for whatever you're using here. So it's not also just about billing people for using queues. It's about having a really, really nice API over queues and being able to use them as resources and just allot them for each client as much as you want and on demand. And the other benefits is having queue in a service-oriented architecture. So you just don't have your message broker installed in your infrastructure and people connecting to it, but you have a service in your infrastructure that does queue. Right, so that's basically the idea, and it is easier to scale. So there's no easy way to scale RabbitMQ, right? So we all know that, like creating clusters for RabbitMQ, that's painful. And same happens for other message brokers. The idea is having a really easy, lightweight queue service that is easy to scale at the same time, and it's completely it's like Lego. You can build it as you want. You can have whatever backend you want, and you can have whatever transport you want. Whatever fits better for your infrastructure. That's the whole idea behind Marconi. So I'm pretty sure there are other benefits, but these are the ones I like the most. So I think that's pretty much it. Yeah. So.
Questions?
I'm thirsty. No.
Hi, thanks. Great talk. Sorry if you actually said this before and I've forgotten, but what was the actual business problem that you were trying to solve at the origin of this? So like, what kicked this project off?
Okay. So the real reason, and I will regret saying this, is the fact that... shut the fuck up. That wasn't recorded. So the real reason I will regret saying this is that we don't have right now a way to provide queue as a service in OpenStack. And it is a cool service. We saw that actually the whole idea, to be fair, came out from Rackspace. And yet again, came out from Rackspace. And like I think November last year or something like that. And the whole point was just that. We don't have queue as a service in OpenStack, and we want that. That's a cool project. AWS has that, and it's working pretty well for them. They have many clients there for God's sake. Yeah. And then we just thought about integrating the notification service there as well, right? And so I also think, I guess, and you can correct me if I'm wrong. I also think that Rackspace is pretty interested in these projects as well, for some reasons.
Yes, if I just may add to the answer. So I think one of the main reasons is that when you deploy systems in the cloud, they need to interact with each other in asynchronous fashion. So it's a very bad practice to have synchronous calls in the cloud, okay, for a number of reasons. And this is where the queuing service comes into play. You want to decouple your components and then basically make interactions between these components ideally work via queuing and messages.
So to complete that answer is like you might say like if I need to do it asynchronously, I could just install RabbitMQ, so you're still not like fixing some issue, right? Because there are plenty of message brokers out there that you could use. So yeah, that's true, but yet again, the whole idea is have all of those as a service. So you can just build a really nice API and be able to say to people, hey, don't worry about installing that stuff. Just use this, right? And you can do that in your private application as well, so that's not tied to anything. So there are two questions. Go ahead, you have the microphone, so you can just ask.
You didn't get very technical, so I wonder what's the difference between Marconi and Celery?
So Celery is different because Celery relies on message brokers, right? So if you want to use Celery, you have to have message brokers behind, or something that does queuing, right? Because it's all based on tasks.
More or less.
Yeah. So if Celery, the idea, I mean, one of the things we want is to create a plugin into Combo. I mean, we want to create a new transport for Combo to communicate with Marconi so that Celery can use Marconi itself. So Celery is all about task. Marconi is all about messages. So Celery basically, when it has a task and I think it's dispatch. When you dispatch a new task, Celery sends a task to the queue. It could be on memory. I mean, you don't need to have a message broker, but you need a queue. So it basically sends a message with that task, sends the task to the message queue, and then it gets the message from the other side and just executes the task. That's what Celery is. Go ahead.
So maybe this is more a question for the Rackspace guys than you, but like, who do you see like being the primary users of this service if you ever deploy it in a public cloud? What kind of like, let's say, what kind of an organization would pay for this as a service? That's.
You can come here if you want that. No, I don't know that. Tell him.
Well, I think. Sorry, I think it depends very much. Sorry, yeah, it depends. The big advantage of anything as a service is that you don't have to bother yourself with this. So, if you have some money, but you press for time or for resources, like for human, for DevOps, then it makes a lot of sense to pay for the service as opposed to being forced to configure all of this yourself and maintain and operate all of this yourself. It's classic, it's a classic outsourcing thing. It's somebody else's problem now. You just consume it as a service. So that's the primary motivation I see.
Any other question? No. Come on. No.
One more question. Can you theoretically use this service as a storage inside Celery, or like write some plugin for Celery perhaps?
Please repeat the question for Word.
Second?
Please repeat the question.
Okay,
for
so
Word.
the question is if in a very awkward environment you can use this service as a storage for Celery, right? I got that wrong? Okay. So yes, you could. It would be really interesting to dig into that. Yeah, I would say yes. You can use it. I mean, you can just like I said, we will definitely write a transport for Combo. And since Celery uses Combo, this is already okay. You can do that.
Yeah, so just use the word backend as opposed to storage.
Oh, you mean for storing? No, I don't think so. I don't think so because no, I don't think so. I mean, you don't want to use it as a queue. You want to use it as a storage for each for Celery, right? No, in that case, no. Sorry.
Thank you for your talk. You said this project scales very well. What exactly do you mean? For example, can you use 2 MongoDB instances, 3, 4 with sharding?
Yeah.
That's possible.
Yeah. So right now, no. But we are already discussing that. We are already discussing a placement service for Marconi. So the whole idea is to be able to have several talking about MongoDB, right? So the idea is to have several clusters of MongoDB, so you can just have a placement service on top of them, which is a Marconi placement service, and it will distribute those messages and queues based on some logic rules, right? So it will know where the messages are. It's like MongoS service from MongoDB. So it knows where everything is, and it will allow you to have separate clusters of every of your backend storage and be able to scale in that way as well. I mean, you can also scale the whole Marconi service. You can also create many of them, but then your bottleneck will be the storage. So we're thinking about, we're already designing displacement service, so you can have several storages, and so we don't have any bottleneck in the whole infrastructure, and no single point of failure.
You said you want to be as fast as possible. Python plus HTML seems to be a contradiction in that.
Say again, sorry?
Python plus HTML seems to be a RESTful interface. Seems to be a bit contradictory about that. We have already seen some cloud database trying this approach and failing. Some databases have also implemented other kinds of protocol.
So let me retry. I mean, let me see if I got your question right. So
one example is most of the time the messages are much smaller than the payloads of HTTP itself.
Right. So you mean we want to be as fast as possible, and you're questioning the fact that we are using HTTP for it, and I couldn't agree more. So we know that, and that's why we're planning, and that's why we created the whole transport layer as a pluggable layer. So the HTTP was kind of is what you're kind of exposed to the public, lines, right? We want to create the DRM as secure as possible with authentication, all that kind of toys you can have in your transport, and making it capable of being public as well. But we know that DRM is not that secure, so there are some stuff that should happen before that goes to public service. But yeah, we know that HTTP is not that fast. And sometimes the payload itself is smaller than the whole HTTP header, and we are aware of that. We're thinking about other compressions, plugins for HTTP, trying to make it faster. But yet again, if the payload itself, if the compressed payload is still smaller than the whole HTTP stuff, it doesn't make sense to compress it at all, right? So that's why we're thinking about creating the DRM one and making tests like see how fast it is, and perhaps have other transports based on lower level stuff like direct sockets and that kind of stuff. Does that answer your question? Cool. Any other questions? Cool. Thanks a lot, guys.
Sorry, I want to remember everyone the code jam of this evening, and we will come back half after 2 this afternoon for the next talk. See you.